You guys can see my screen?
Yes.
Okay, cool. Just one sec. All right. Uh, yes, then guess we can start. Hi, everyone. Um, so on today's topic, we're going to talk about RAG, or Retrieval Augmented Generation. Um, it is pretty useful application for you to know, and it's good to understand its components and applications and how it works and this kind of stuff. That's what we're going to be talking about today. Um, for some of you who have not yet started with your projects, this can be helpful. Even for those who have already started, this can be helpful to sort of understand if this is needed for you to incorporate this into your application. So retrieval augmented generation. We're going to talk about this, but for now, I just want to draw your attention towards um, the uncomfortable truth, so to say, that most of the demos nowadays they're just basically nothing interesting other than just an LLM call. So technically, like companies are just taking LLM, plain LLM, providing some prompts like, okay, you're this assistant, you're solving math problems, etc., etc. And then they're sending requests to, I don't know, OpenAI or Claude or Gemini, whatever. And they're just demoing this. Like they're saying, yeah, all right, you know what, this is what kind of thing, what kind of system we build. But in fact, underneath the hood, what's going on is just a basic API call. So I mean, maybe 2 years back, it would have been very pretty, pretty looking, and today as well, I guess. But it's just like it is not scalable in a way that you can't really control it much other than the prompt, and you just can't have so much inputs. Like imagine we want to ask a question about a book, right? A book is 400 pages, and what do we do? Like, are we just taking all of those text inputs from the book and feeding the OpenAI just to answer one question? I mean, is that reasonable? Probably no. It will consume a lot of tokens, a lot of, I mean, it will be very expensive for stuff, and it will be slow. I mean, if you send so many things, and it's just sometimes we don't even have this like this window, the context window so large as as if we can fit a whole book inside. So we're kind of bounded in situations. So LLMs alone, like they're pretty all right, like, but um like yeah, like I said, they're too expensive. The knowledge can get stale, like outdated, and we are not. It is not the optimal approach, honestly. So when like people, like some companies might have like this. I mean, whatever, like 1 week system building. They build a system in 1 week, and they're demoing this, like just a LLM, an LLM calling, and surprisingly in demos it will look good because the management will never know like what's going on. They just got the perfect results. They just saw the perfect results, and yeah, I mean that's pretty much good. But what they don't probably show to the management is that uh, what are the edge cases, right? So in fact, in edge cases, the system will fail. So the thing is, we need production ready AI, not just a plain API call. So that's something we want to be talking about today. Um, so production ready AI is just something that has the grounded answers, fresh sources. Like imagine we get all the new stuff every day. Like every day, data is changing and everything is changing. For example, if you want to just say, I don't know, create a system that is kind of answering any questions about news, and you're using, let's say, I don't know, like GPT 4.0. The GPT 4.0 was trained, I mean, like maybe two years back, if I'm not mistaken. And if you ask any question, it doesn't even know what's going on today, right? That's like kind of weird to build that kind of system. Of course, if you ask like solve this kind of math, I mean, with math, it's going to work most probably because it doesn't depend on time anyhow. I mean, arguably. So we need fresh sources, so to say. Very often, this is the case. And we need some kind of quality and measurable in a way, and that users can interact with this and, um, you know, uh, don't just get the users need not just get the basic answers like generic stuff. They need a proper knowledge. So that's how the like, just plain LLMs fail. That's what's going on. Um, rank is something more interesting. It's more designed for the use cases when you have a lot of data. Like for example, the case with the book. If you have a large book, then this is the way you need to go. So yeah, like I said, like just plain prompt engineering will be good for demos and stuff, but it will not be scalable at all. While the RAG system will be pretty good, it will have all of the data and it will catch all of the data pretty easily. And you do not need to send all of your data to the large LLMs to be processed. And that means that it's going to be cheaper for you to use a RAG. So yeah, you might want to be thinking like, all right, I've got this kind of problem, right? Like whatever problem you want to solve, you want to be thinking, all right, what should I choose, right? Like what is the right path to take that will that will be cost effective, efficient, and it will be scalable so that it can serve a lot of users, a lot of people at the same time. So the use cases they differ, right? So for example, like we need latest facts, for example, like the first one. If we need latest facts, if we're building like a chatbot for news, answering any news, I mean, do not like I said, you should not be using like just plain LLM calls. Um, there's one more thing called fine tuning. Like fine tuning is more like you're training your network. Like you add more extra layers. You train all those extra layers, and then but you're freezing the whole network. But fine tuning isn't good because you'll be like every single second new data can come, and once you're doing the fine tuning, it's only bounded to the data set that you have. So RAG is the best solution in this situation. Actually, it works. Even if new data is coming, you don't need to update your system anyhow. It's going to work. So that's pretty useful. So wrong tone or format. Uh, yeah, I mean, in this situation, RAG is kind of arguable, actually. It could be useful, could be not. Fine tuning will be more interesting, like, because you will be, yeah, I mean, you'll be providing the kind of tone you want, and it will learn that kind of tone. Although with RAG, you can obviously like add the tone thing in the LLM part and say um, you need to be using this kind of tone, which might work, might not be the best. I mean, it depends. So you better use it to try. There are some other way of things, some other examples. So if you need, yeah, a lot of the use cases, so to say, it's just will depend on your use case specifically. Let's just talk about like the production rack architecture, like what it is, like how exactly we're building this. Um, so we have two parts with rack. First, we need to build the infrastructure. We need to build a way to get the data and run the system. And then the next part is basically to serve your system. So first, what we need is documents. You definitely need documents. It could be any documents you'd like to have, PDFs, doc files, or any other extensions. I mean, RAG is usually helpful if you have like text and data related stuff, so it will do a pretty good job. And since the data set can get very large, like for example, imagine you have, I mean, I don't know, like 10 PDFs, right? And every PDF has 100 pages. What do you do? Like, you can't just take all of that data and just fill in with the system. You need to chunk them. Like, you need to split the data into chunks. And once you split this data, once the data is split, then you embed each of those components, like the chunks that you have split, with vector dimensions, so to say, and you store it in your database. So when working with RAC, we need vector DB. Most probably, some of you have never worked with vector DB, but you might have been working with relational DBs like SQL type. But vector DB is something very optimized for vector types. If you have vectors, I mean, if you're like, vector is just a sequence of ordered elements, so to say. And this is very difficult to store and work with when it comes to relational databases, like, I mean, SQL type, or no SQL, MongoDB, or etc. So yeah, we're gonna talk about this a bit later, but yeah, once you split your data, split your chunks, embed your data, store in your DB, this is the first step. Your system is kind of ready, and you just need to deploy it in a way that you will receive a user query. The user query will be embedded, and so it will use the same embedding algorithm that you were embedding your chunks. So here we're embedding the chunks of data from our PDFs, while here we're embedding the user query. Like, for example, user says, all right, just find me what is the largest, I mean, planet in the world. If you have like data sets of planets, each planet has its own, let's say, PDF file. It's going to go and search and find the answer for you. So, but first you need to embed your query, because if you embed this, you can check whether it is similar to this embeddings or not, so to say. So that's what you do is like you apply a similarity search from your vector DB, and you find, let's say, all right, let's say we've got like 10 PDFs, right? And say we split every PDF, every of those 10 into chunks, and we obtained overall 1,000 chunks. Okay. So your system is going to embed your user query and search inside this 1,000 chunks, which of this 1,000 relates to this user query. That's the basic idea about it. So we're going to find the top similar chunks. Let's say we can choose, for simplicity, first 10 similar chunks. And once we find this 10 chunks, we just concatenate them together and make one single unit and then pass it to LLM, which is kind of a large language model. Technically, you can just send it to ChatGPT. I mean, a GPT model or whatever model you like, and it will answer any questions based on your findings. So this is how it works for the production RAG. There are more advanced RAG architectures. We're not going to cover that today, but there are like a lot of the systems you can build. You can add agents, you can add guardrails, you can do like this is the simple basic RAG, but you can have like bidirectional RAG, like two directions. This is for one direction only, but you can have two directions as well if you want. So, but for now, I just recommend you to, I mean, it's pretty recommended you try first. If this is working pretty well, then you don't need to think twice, right? It's working, then you can demo this to your, I mean, clients or your investors or whoever you want. So, but there's just a lot of the stuff going on with RAG. You can't just do this right away. There are like some strategies, like you need to do like you need to connect to your DBs. I mean, I don't know what kind of data you want. This is just PDF. It's easy. You don't need to do anything. You just store them in locally, but it might go to the point that you need to connect to website or a social media or some Slack platform or anything else to collect data from there as well. First you do the connection, then you remove your, I mean, the stuff that is not needed or unuseful. Then yeah, you apply the rest of the stuff, embed chunk, embed index. Basically, that's pretty much it. You guys have any questions so far? Anything you want to ask?
For me, so far, so good, but I don't know. Guys, do you have any questions? I think we might have questions closer to the end of this presentation, where like when we know you said everything you wanted, and then we have specific questions, for example.
Sounds good. Yes. Yeah, even if you can just leave the questions in the comments if you want. Yeah, I'm gonna answer them. So, you might be having this kind of raw document, say pricing policy, right? And you'll have a couple of things, like for example, starter includes 1,000 credits, pro includes 5,000 credits, enterprise has custom limits, refunds within 14 days, this kind of stuff. And you might be chunking, let's say, I mean, will be like practically useless, but it's just like an example for you to sort of understand what's going on with the chunking. So you might want to chunk, let's say, pricing and starter. So starter, this part. You might want to have chunk A. This is chunk A. Chunk B would be your pro credits. And chunk C will be this. So you just have the whole document. You chunk this into 3 parts, and then yeah, that's pretty much it. It's just easy like this. Sometimes it's easy. Sometimes it's easy like this, but sometimes there are multiple ways to chunk your data depending on your document for sure. So if your documents have very clear structure, like they have sections and paragraphs and stuff like this, you can have like one chunk is one section or one paragraph if it's not too large or anything. But very often our data is not that much structured. So unfortunately, we can't apply this kind of strategy. And it's often useful just to do random chunking, like random. I mean, it's not very random, but you just take, let's say, first 50 characters, and then second 50 characters, and then third, and etc. So you go one by one like this. But of course, it's better to have the chunks meaningful. Like it's better to have them split down into some meanings, so to say. Otherwise, you would have like random chunks. So let's talk about semantic similarity. Why we need this? So yeah, so like I mentioned, you got 1,000 chunks, right? And now you want to search user query, say what is the closest planet to Earth or something. And then it's gonna go through this 1,000 chunks and find the similar items, which ones are similar to what we just said. And there's this thing that we need to have embeddings for that. For example, I don't know, cheap hotel in London. This is our text, and an embedding would look something like this. This is, of course, this is approximation. Every model will work differently, but and then if you have another query like budget accommodation UK capital, so you kind of understand, like as a human being, like you understand that these two things are pretty much similar, right? And what that means in the vector world, so to say, it's that every element would be similar. Like this, and this are similar. Like they're very close to each other, right? Or second one, they are very close to each other, or the third one. So that's how you kind of understand if this is close enough or not. And if it's not close enough, then they're not related at all. So coming back to our query, if a user says, find the closest planets to our planet Earth, then basically we will find the data that is like this will be your find planet close to Earth, and say this will be one of your give me a sec. This will be something like the closest Earth is, yeah, whatever it is. So you see, like these things are very similar. So we'll find the closest ones, and that's basically it. Um, so cosine similarity is all right. We have like three different scenarios, but actually there are multiple different scenarios. But I just want to draw your attention to the three specifically. You can get so first of all, this is our formula. This is our formula. You have your first vector, second vector. You just multiply them and then divide by their lengths, multiplied lengths, so to say, and that will give you some number. The number is, it can be one. For example, in this case, these two are very similar. So I assume like, so they're like cosine similarity would be something like 0.96, right? It's something close to one. They're pretty similar, right? And but they can be not similar at all. Like they could be like, if a question is about, say, planets, and your DB has questions about, I mean, vehicles or cars, then these two have nothing to do with each other, right? These things will be completely negative, like there will be completely unrelated, so to say, or dissimilar. So in that case, it will be zero. Cosine similarity could be -1, but it is like, it is very rare, so to say. But if you think about it, so you might be like confused. What is like the difference, right, between unrelated and opposites? Just two things. So unrelated is like we have nothing to do. Like these two things are not at all, like they are completely different things, different worlds. While opposite is something that it could be related, but it's related in an opposite way. For example, if I say um, an example, I could bring you like I love, say, this product, right? And I hate this product. These two are similar in a way, but they're opposite to each other. So this will most probably give you like -1 cosine similarity. Um, yeah, that's what it is. So basically, we're interested in RAG system, in RAG pipeline. We're interested only about the closest to one cases. We're not interested about 0 or -1. Although -1 could be helpful in certain situation, but most often it is about being similar, so to say. So yeah, I mean, you can draw your vector embeddings in a two-dimensional space. For example, the budget accommodation in UK and cheap hotel in London, they would probably be around this area. Like you see these dots that are very close to each other. They're very similar. So they have this similar direction. If you point this from this point 0 to them, they will be close to each other. While if you talk about, let's say, legal or, I don't know, lawyers, um, government, they would be on a different side. Or if you speak about uh, cars, vehicles, they are different as well. So that's basically what how we can visualize and understand. So you know what these things are, how these things are similar or dissimilar, or yeah, this kind of stuff. This plot very often helps. And there are different use cases that you might want to use RAG. And but this is often, people usually often use this for some kind of assistance, for example, like a support. Let's say previously a company had been hiring 10 people for support, and they would speak with the people, with the users for their queries, and they will answer the questions from their DB. But now it is uh, kind of automated in a way, like people, they just take RAG pipeline, they utilize it in their system, and this is just very efficient, and users are happier because like their results are pretty quick. But I mean, of course, it's not as mostly it could maybe human feedback is kind of better, but this kind of system is very useful for a lot of the support kind of applications. But most people, what they do now, they kind of understand that, you know what, like humans are mostly answering better than the AI. So they have like this kind of hybrid system. If AI fails, then call a human and the human will answer. So this is a basic use case. Sales assistants could be useful, legal doc review, internal search in your whatever data you've got. I mean, you can store them in different places like Slack, Notion, Jira, or Google Drive, or whatever you store it. You can retrieve that and get answers pretty quickly by AI. Or an onboarding tutor like that helps, let's say, small kids to do stuff, like to learn basic stuff like math, or it can be for students, or anybody else. So this is also very popular idea. And code-based assistant as well. This can just guide you throughout the code and how the code is structured, maybe syntax or some documentation. So these are just some basic ideas for you to think about. It. Of course, there are a lot more. It's just like saying, I'm just saying that if you have collected some kind of data and it's very large, so you might want to think and consider RAG pipeline in your whatever system you want to build. So yeah, there are a lot of the improvements to the RAG. I'm just gonna tell them with basic wording, but of course it's worth to play around and see which one works better. But for every use case, it will differ. So I can't say like there's an ideal way to solve a certain problem with RAG, but what we have discussed is just the basic baseline. Fast, it's very fast, and it will retrieve the data very quickly for you. And yeah, you can just try this first, and if it fails, you can go up through this pyramid, and there are different other approaches like hybrid search. So if you want to catch the exact terms from your query, or you can add reranking that sort of instead of taking, let's say, 10 chunks as similar, like 10 similar items from your DB, you take 50 instead of 10, and then you evaluate this 50 separately. So like it sort of adds another like second layer that will reevaluate this 50 again. But of course, this is going to be costly and will be slower, of course, but maybe the results can improve. Just you can try that. And query rewrites. If a query, if a user query is not clear, I mean, we are in a rush very often, and we might write something down, and there will be no meaning, or like hard to understand, and it's vague. So the AI will rewrite whatever the user has said, and it will sort of decipher this into AI wording so that AI can understand better and find better in the database, so to say. So there could be a lot, like you can integrate a lot more. You can add agents, routing, like multi sources. But of course, these things are costlier and it will be slower, but maybe your results will be better. So it's nevertheless it's worth trying some of this and seeing which one is working better, so to say. Um, yeah, so prompt assembly, it's basically um, like just an example for you to kind of understand. You can have, this is just basic example. You can decide yourself. It's not that you need to follow this, but you might think it in this way. If you want to store your tokens, so for example, you can have like system prompt that says, all right, you know what, you're a helpful assistant, you can do this and this and that. You cannot judge anyone and say anything bad or this kind of stuff. Just be polite and etc. um, and it will consume it's I mean, generally it's not the large part of your token consumption, so it just follows like, let's say let's say this much out of this full pattern. A user question could be small or large. The largest thing in general is the retrieved context. That's what you retrieve from your rack system, like with the kind of chunks. Let's say if you've got 10 chunks, they are huge and you need to store them, you need to deal with them. And once you pass them to your LLM, the LLM will consume tokens out of it. So it will be generally the largest, like most of it in most of the applications, it's just the largest part. You can have chat history if you choose to have one, but I mean, it's optional. But if for it's just an example, you can have chat history that remembers, let's say, last two dialogues that you had and this kind of stuff. But be careful with chat histories because it can actually be very inefficient and it can consume a lot more tokens and become a super expensive system that you don't want to deal with, so to say. And of course we do the outputs, right? Like we need to output the result in a way. So there are like input tokens and output tokens in general, but bear in mind that output tokens, they're more expensive most of the time. I think they're like in general like 3 times more expensive. Like let's say if your input is, let's say, um 10 words, 30 words. Let's say your input is 30 words, your output is 10 words. Then this two will be approximately the same. Let's say you pay for your input tokens, 30 words will be like, let's say, $1. And for output token, 10 words would be again $1 because it's 3 times more expensive. So it's just an example to give you. So yeah, if we can, but it's not always the case, but practical rule says to us that pass fewer, higher quality chunks. If you can make that kind of system that can retrieve the high quality chunks, not just random data that has nothing to do with your system, but high quality chunks, it will make much sense. So it is very often that we provide a lot of details for the system, and we provide a lot of data, a lot of context, and it can actually, instead of helping, it can actually harm. So just think about this twice before doing this. Not to mention also that this is a lot more expensive, and for the enterprise level, it can go too expensive, so to say. So yeah, we kind of need some stuff, like some way to evaluate a RAG, to understand. All right, so you build your RAG, no, and you build, like, let's say 3 different systems with RAG. Like, let's say you build one um, with basic RAG, second system was reranking RAG, and this the third one was agentic RAG. You want to know which one of this is better, and for this you kind of need to build a very proper evaluation system. There are a lot of metrics for that, and with RAG, it's generally like you wanna build you wanna evaluate 2 parts: your embeddings, like how good your embedding model is, and the second one, how good your generation part is with LLM. So technically, um, like what I'm saying here is like this part needs to be evaluated separately, because we want to understand actually this part. We want to understand, like, if the chunks retrieved from our DB, are they relevant or are they not making sense? This is what we want to understand first. So if your database data is related or not, and if it's retrieving the right things or not. So the first thing, and the second thing is you want to understand whether your LLM deals with how it deals with your chunks. So if these 2 systems are working good, then you're good to go. If some of them fail, then yeah, you get the idea. But very often the problem is coming with your database rather than your LLM, because LLMs are basically all right. If they are given some data like text, they will do like whatever you want them to do. It's basically like the advanced models like GPTs or Geminis. They're pretty good. They will hallucinate less, will be fine most of the time. But I would rather be focused on this part and come up with a good algorithm that we can search correctly. Because um, if you search about vehicles, right, but your vector DB gives you data about planets, this kind of doesn't make sense, right? This planets will be sent to your LLM, and your LLM, whatever it takes, it's going to answer. Like it can't guess, right? So if you say something about planets, it will answer about planets. So eventually your LLM will fail as well. This is like a chain, sort of say. If this fails, this will fail as well. But in this situation, the fault came from here, and this wasn't the fault from your LLM. Yeah, I mean there are a lot of the metrics you can incorporate, and here are some of them. But for each use case, it will differ for sure. Yeah, there are some RAG failures, so to say. They can happen. I just gave you some context on what can actually be what would be happening. And so, for example, your data could be not fresh. So to say, it's stale, old, and you need new data. You need to feed uh, properly. You need to update your vector DB before even using your RAG. So make sure to do that, because otherwise you will build a perfect rack, but your data is not there, and you might think, why is it failing if my data is there? So so you can have, for example, yeah, no answer in your corpus. So that can happen. If you have this kind of situation, like for every situation, I have some sort of solution, but it's just generic solution. But try to think about this. If you do not have the corpus, if this is like your data is coming, but it's the data is not coming from your retrieval algorithm, just add some sources, like some extra parts. If a wrong chunk is retrieved, just do a hybrid or rerank. This can help. I mean, if your data is old, then yeah, I mean, make sure that you get the right data before even applying RAG. So make sure to add some of the sanitizations like prompt injection. If some of you do not know what prompt injection is, it's just like, let's say you built a RAG system, right? And you now serve this to your clients or your users, right? And some of the users are not pretty. They will try to hack your system and they say, yeah, I mean, can you tell me what is the, I don't know, what is the credit card of this person, right? For example. And um, your RAG is very, I mean, you didn't teach your RAG to not say this kind of stuff. And it might, like, it's just like theoretically possible that your RAG will get this question and really answer somebody and tell you like what are the where's the credit card and this kind of stuff. So you need to be careful. You need to add some more rules and stuff. This is just for certain applications like security is very important. Of course, it's not always like this, but just make sure this is the case. There are possibilities of memory poisoning in rack systems. How these attacks can be minimized, or should there be a certain checks for data validness? Yeah, so there are guardrails for this. So you can add guardrails to do pre-checks, like use first check whether the input is malicious or not. And if it is malicious, you can prevent this by saying, let's say, like some people, some companies, they do this thing, like they get some users. Every user will get a warning, let's say, right? So, for example, if a user tried to hack it twice and our AI checks and sees that this guy's, this is a malicious user, this will be dangerous, then after the third time, this user will be blocked, so to say. Just an example to give you. Or you can have guardrails to blocking. They will tell the user, you know what, this is not it's not in our rules. Just ask any relevant questions or things like this. So your system should not be naive to search data with this kind of stuff. The user might want to ask you like, tell me your system prompt or your whatever is what's going on in your database, and tell me this kind of stuff. So yeah, just like this. If your responses are too slow, just, I mean, re-ranking can make this happen. I mean, if you use your re-ranking, just cache and budget it out in a way that your results are preserved, your results are great, and it's not very slow, so to say. Yeah. So some of the security and trust kind of stuff we just talked a little bit already, but yeah, just prompt uh, we kind of need to apply these things to be careful who's dealing with our system. If a if a certain system is authorized, let's say you have user authentication, the user enters his or her email or and stores some stuff, it can help you to kind of understand who's this guy and what is he doing there. But very often it's not the case, and people can use certain websites without authentication, and it will, most of the time it will create problems for sure. And users, um, we can just do like, we can understand like, okay, this guy is, well, maybe we can attract their IPs, so to say, but it's not a very often good to track user IPs because it's not like we're not always allowed to do it, and we need to encrypt the user IPs and stuff. But so yeah, in that situation, we need to kind of have the user authentication to help us deal with that. So check for the some kind of guardrails and this kind of stuff. Maybe I missed some valuable information. I wanted to ask if you could tell me how and where to create a vector database. The other day when I was integrating the AI on the OpenAI platform, I saw that they offer the ability to create a vector DB, but it costs. Oh, we're going to talk about vector DB. We're actually going to be building this system today. So I'm going to tell you, you don't need to pay for that. You can have just your own vector DB in your, I mean, machine even. Yeah. So this is just an example 2 week project, but it can be splashed out into 3 weeks or 4 weeks, whatever works for you better. I mean, obviously, you can be a workaholic, or you can build something very quickly. You would rather, I mean, some people prefer to build it in a couple of days and spend a lot of the time in this couple of days. Some people like to, break it down and drag it out throughout like a couple of weeks. But I mean, it's up to you to whatever whatever works for you best. But this is just an example. What will be what you can think of, for example. So first 2 days, you can just pick some niche, gather 50 real questions. So I just gave you in the beginning the kind of applications you want to build with RAG. So that's basically like some kind of support. Think of it as some kind of support, but not only actually. There are many use cases, but support is the most popular one. Pick a niche. So gather some questions. Gather the data sources next. So maybe 3, 5 data sources will be enough. Make sure to have the metadata, because metadata can help you to organize your data set in a better way. So days 5 to 7, just basic RAG, basic, like the basic one. I'm gonna just be, we're gonna be sharing with you a basic RAG with the code, and you can just actually copy paste if you want and build on that. If I mean, that can save up some time, but it's up to you. So yeah, you might have the citations, UI, um, just for some of you who are like into coding and you like to code, it's good, it's very good, but just to be more efficient, I actually recommend you to be more concentrated on the product than writing a perfect code. Perfect code can be great, but it can extend your work and it can make things slower, so to say. Because nowadays I mean, a lot of people, they're just using AI to write their code, and but you can, what you can do, you can just do the code completion by AI, and then you can just go around and see like if AI did whatever you wanted, just pre-check before proceeding, and that should be more than enough. So if you do not know certain languages, for example, if you want to build some UI feature, like you've always worked with Python and never had any UI or this kind of stuff, and you need like to have a JavaScript, just don't think about learning JavaScript. It doesn't make sense. It's just go ahead with code completions. It's just UI. So we can use open source DBs, I think. Qdrant, yeah, sure. There are many open source DBs, and that's a good idea to go with one of them. Qdrant is helpful. Milvus, there are some more. Um, Tajikistan's Academy. No, if that question was to me, no, I'm not. Um, okay, next, you once you build your thing, whatever you're building, try to set up some evaluation metrics and see if your system is working fine. Just be careful to catch up some of the mistakes or of some of the failures and stuff like this. And let's say, okay, you pack these things up together. The things are working pretty fine. Now think about improvements, but leave these improvements for the last couple of days. Maybe you want to add a re-ranker, or you want to add the guardrails to prevent some sort of prompt injections and attacks to your system. Pilot users can be useful as well. So yeah, this is just for you to experiment. This part are for experimentation, but this one is this four steps are kind of must, so to say. So again, this is like an example. I'm not saying this is always like this. It can be different, but if you're applying just a basic RAG, right, it will cost you less, and the latency will be less, and yeah, it will be good. But the results, the accuracy might not be the best. So in that situation, you want to go ahead and think about hybrid mode or hybrid process re-ranking or agentic RAG. So you have some agents and a lot of more. But again, you see like the cost will increase, your latency will increase. And do you want that? I mean, of course, you want this if this significantly improves the results, right? But if it's not significant, I would rather just not do it and pick up the baseline, like the basic way to go with it. Yeah. So if you collect like some of the FAQ, frequently answered questions about something, let's for example think about refund policy, and ask a question: can I get a refund after using 200 credits? You will get retrieved chunks, citations, and yeah, this is just for you to think about how you can deal with your chunks. So think of it as understanding if the stuff is relevant or not, the user query is relevant or not, or question is out of topic, or this kind of stuff. And if you figure out, let's say, okay, this user is asking a reasonable question, why is my system failing? You might want to go to your database and see the kind of chunks that you retrieve, are they really what you want, right? Because if they're not if they're not retrieved correctly, you might want to find better chunking strategies. Like I said, you can apply maybe larger context windows. Maybe you can think about maybe your embedding model isn't great. Maybe you want to get a better embedding model that will create, say, the vectors for you. And yeah, you can just play around with this kind of stuff, and it can help. So yeah, we just talked about this stuff already. So yeah, what you need is just data set, this kind of stuff, metrics, trust, this kind of stuff. It's just, I mean, goes without saying. But I'm not going to into this interactive thing, but so yeah, there are some more rack pipe like rack systems. We're not going to talk about them, but just think about it in certain situations. They can help. For example, you might have, say, instead of text, you could have both text and images and maybe some more stuff. And this is like becoming very complicated because you have different data types. In these situations, I do not recommend going with the plain RAG. Build a multi-model RAG. And what it means is for each embeddings, like you might have two different embeddings. One embedding deals with your text, the other one with your images or tables and things like this. And then you, in a way, at the end, once you have the vectors from all of this images, text, and other data types, you need to find a way to clip them together, so to say. So you need to have them merged so that they make some sense. So there are very different scenarios where, for example, you can have a human in the loop, and the human can yeah, in certain situations, like your AI will fail and you need a human in the loop. And this is also helpful in, for example, in the support when yeah, your AI fails and your user says, you know, just bring a human. I'm tired of you. Just then you want to have this kind of system that is some kind of hybrid system. There are many more, like agentic RAG, where you have different agents to do some kind of job. I do not recommend going with agentic RAG. If your system is working with simple RAG, why would you need agents, and why would you need to spend more money and resources on this? But of course, if your RAG is failing, then agentic RAG can be powerful. If your system is very complex and you need to divide instead of going one way, so to say, you need to divide and then bring these divisions back together in a way. So agentic RAG can help. GraphRag, say, GraphRag is actually, let's say, you have some connections. Say, if we're talking about, let's say, movies and actors, right? So every movie will have its actors and they can intersect. Like, for example, one actor can play in different movies, and then it's just like it can get very complicated, but there is this relationship, right? So everything is related to each other, and you might have a question like, okay, find me the from the database, find me um, the movies that I don't know, Jim Carrey played there, and it was drama, say, like this. And there are like a lot of connections here. You see, you need some sort. If you have this connection, then you can build a graph, and this graph will connect each dot to everything together. Then this is like obviously a graph rack. Go ahead with graph rack. But if it's just like random stuff in your database, there are no connections at all, like no whatsoever, then basic rack can help. Multi-hop rack, you know what? You might have different things, like different kind of data. Like imagine a user says, all right, you know what? What is the difference between property A and property B? So if you send this kind of query into your database, it will be kind of awkward, honestly, because this question contains two parts. You need to divide them in a way. Maybe you need to create an agent that will divide your one question into two sub questions, and every sub question will go through your rack. And maybe maybe one thing will be found from your DB separately, and the other thing, it will find some data separately as well, and then you can concat them together. Very often there are multiple effects in your database, so you want to deal with multiple stuff separately. That's just my advice to you. If you have multiple things going on, just split it out. Do not send this query that has a lot of stuff in one single query. It will be useless, because you will not be getting the proper results from your DB, so to say. In your opinion, is it reasonable to use vibe coding if, for example, you need the product to reach production faster? So yeah, you know what? Like, think of it as this is your product, right? So um, when you look at this product, you want to see the results, right? You don't want to see the code. Like, you never show to anybody your code. That's the problem. I mean, it is a problem, or this is not. It is a good thing. I don't know. It's arguable, but the thing is, the thing is that you if you build this good product and then you can find a way to evaluate it without code, like let's say you did the wipe coding, right? And then you send some questions and see if the results are correct or not, then why not? I mean, wipe coding is it's very popular, and it will reduce your time frame of building anything. And yeah, I mean, you don't want to be sitting down building a startup for 1 year before showing this to investors, right? You want to build something that it is like as minimal functionality. You can build, you can show this to people, and they can test, and if it works, you get your reward after this. Then think about other stuff as well. But for now, I don't see any problem with wipe coding. as long as you manage it right. I mean, as long as you test it and do not just drop your, I mean, you see like you build a product, you use it for one example, it works, then this is not the case. It's not going to work. You need to do like edge cases, you need to do proper evaluation, and after that, you can feel like this is working. So I saw somebody was raising the hand, but I lost a person. Okay, all right. All right, maybe you can go ahead. Um, so can you pick one of the problems you mentioned earlier and give us an example for using RAG versus fine tuning? Yep, yeah, sure. So for example, let's make something out. Let's say, um, okay, fine tuning and RAG. Let's say we wanna we want to be dealing with counting, let's say, something. And let's say you want to count um, how many, I don't know, how many dogs are in a picture, right? What you can do is you can just send this image to ChatGPT. Actually, I can just open now ChatGPT and send you like an image of a dog, and it will count for you. It will say, okay, there are two dogs in the image, and yeah, it's good. Uh, but will it be efficient? It's not going to be efficient because you're solving a very simple problem, but you're using LLM to do the job for you. And unfortunately, a lot of companies, they do this kind of stuff. They think this is the reasonable way, but this is very expensive, and very often it might not work. It might not work. So this is fine. I mean, I just brought you an example for actually this doesn't, we can't relate this to RAG, sorry, but we can relate this to whether we need to use like an LLM or fine-tuned model. But if you want with RAG, then we need some database. For example, sorry, this wasn't actually not very relevant here.
So
Let me think.
can you use fine tuning for dog counting or?
Yeah, absolutely. We can just have small model, not large LLM, and gather some data set for dogs, and yeah, annotate it if there's no annotation, and train your like fine tune your some smaller LLM on that, or small SLM, so to say. It's small language model. Um,
So yeah,
so
then it was a very good example where you choose not RAG, not LLM, but you choose fine tuning, right? That's a good example, actually.
yeah, in a way, if we do compare this three, then yes. Um, so let's say we've got like FAQ, okay? You have an FAQ that is not changing. So frequently answered questions about something. Say we want a refund policy, right? If let's say this is never changing, but I mean, it can change, but let's say it's not changing, right? In this situation, I think like okay, let's refund policy can actually be small, but if it's large, like we have a lot of policies, let's say we have a million policies, let's say, right? Um, okay, like refund policy, well, maybe some other policy or some other thing that will make sense here. Not refund, but um, um, okay, all right, FAQ. with school behavior, let's say, how people need to behave in school, let's say, just, but imagine you've got millions of millions of questions and answers, and millions of questions and answers. So if you would use RAG here, then you would wait, let's say, 10 minutes to retrieve something, which isn't very useful. With fine tuning, you would wait most probably, I mean, so, and fine tuning will help, would be better here if you want accurate, good accuracy, because if you have millions of data, imagine like a lot of this stuff is useful, and I mean, I don't know if this can solve your problem or not. Most probably, if you have a lot of data, and with RAG it goes like very slow and very expensive, maybe fine tuning can help, as long as you have the data. Like I mentioned here, you already have the FAQ, questions and answers. If you have the data, go. I would most of, like, almost always go with the fine tuning rather than RAG. Question. For example, in my AI-powered startup, everything is currently based on a system prompt. Okay. If we receive significant investment, example, $50K, should we move beyond system prompts to something more advanced like RAG or fine-tuning, or is it a system prompt still enough for production? It's very it will differ from AI powered startup to AI powered startup. I don't know exactly what kind of problem you're solving, of course, but I would not go ahead with any RAG or anything, as long as your problem, like, okay, I assume your AI powered startup is solving some problem, right? And if your problem is solved with your basic prompt, and you're sure in that, why would you need to complicate your system? That would be my question. But every use case is different, so I don't know. This kind of stuff like RAG fine tuning, they might not, they might even harm you. So, but think about it on a different angle as well. If your system is so easy that you can reproduce this with basic system prompt, right, in API call, don't you think you'll have a lot of the, I mean, everyone can make it in one day, right? So why would somebody invest in this? Just think about this in this way as well. But yeah, there's no ideal answer, I would tell you. So yeah, I think we're approaching the end of the slides, and we'll start with the coding part. Yeah, some of the checklists that you need to take care about before moving ahead. So let me just, yeah, I was not accidentally thinking about talking about this planets. I actually built this PDFs, generated them actually. So they're kind of vague, but it doesn't matter. So I haven't written this. It's just like random generated stuff about every planet, right? And you get some data for every planet. Uh, and the data is not small. Look at this. If we collect this everything inside one large document, right? It's not small. It's like what, like a lot of the inputs, a lot of the tokens. And actually, if I just send this to ChatGPT now, it might say, all right, you know what? It's a lot of the data, just pay for the pro subscription or whatever. So yeah, you might think of it in a different way. So you don't want to spend your money on sending the whole data to your LLMs, but rather you're pretty sure now that this system can work. The system is not bad with RAG. So, and what I can also notice is that we have a structure, right? You see the structure everywhere. We have overview. Um, Maybe some of the sections are different, but in general, we have some sections, right? Sections are, it's not that big. They're small. So think of it as chunks. So maybe you can have every section as your chunk. Why not? This is a very good idea actually in this situation. Um, so yeah, that's that's my data set, so to say. Um, and what we want to do now is we want to do a simple intro to the coding part. I'm going to be using ChromaDB. This is the one of you was asking me this question about if we need to use the paid versions of OpenAI vector DB. Probably no, you don't need that. You can just go ahead with ChromaDB. Very easy to use, and you get a lot of the access to your data a lot more efficiently. So yeah, what you can do is you can import the embeddings. OpenAI. I'm just going to be using OpenAI for this simple project because it's easier. But of course, you can go ahead and use local LLMs or Hugging Face models or anything else. But for simplicity, I'm just going to be using AI embeddings, OpenAI embeddings. So .env, if you have an environmental variable, like I was mentioning in my last session, just store it in your .env, your OpenAI keys and stuff, and you can load it here very easily like this. Just 2 lines of code. You do .env load, and then yeah, this will read your env. I'm going to import OpenAI, a Python library for dealing with PDFs. So it's PyPDF, it's called. Um, so, so I'm just gonna go ahead with the PDFs. Create a, actually this is not, one sec, it's not gonna be useful now because I already have the data. Load text from PDF. Yeah, here is what we actually need. We need to, this PDF, if I open it right now, you see this doesn't make sense, right? It's just encrypted, so to say. We need to decrypt it in a way. We need to use a Python library to do that. We need to extract the actual text from this. For example, here I had the PDF, Mac, Apple-based, like preview package that reads this stuff. But generally speaking, you can't read this kind of stuff. You need a way to extract this. So that's what I do here. I extract the text, the pages of the text of the PDFs. I do the chunking here. So I'm actually having 500. It's a chunk size 500. That's basically you go over the data and collect 500 characters. So for example, like here, I would go ahead with say 500 characters. Maybe it's ending somewhere here. And then from this would be your first chunk. And then the second chunk would be something like this. And then like this. In this specific example, like I uh, told you, makes much more sense if you use the section wise approach. But for now, I'm just gonna go with chunking because with chunking, like this kind of chunking, but that has some fixed number of characters. This is working mostly a lot better than with section-wise approach because I mean, like for 90% of the use cases, PDFs are not structured like this. We're not having this kind of structure most of the time. So therefore, this way is kind of better. So I'm going to be using that. So yeah, that's the algorithm I just told you. Like you go one chunk by chunk, but here I use actually overlapping chunks. So that's basically um, if you the overlapping one is so here that I shown you like if you go like this is first chunk, right, and this is second chunk, and this is third chunk. This would have been like overlap 0. Um, but we need like some overlap. This is helping sometimes. I would just recommend you to do that. Yeah, sure. I can zoom in the code. Is that better? Okay. Yeah, I'm just gonna. Yeah, I see some questions. I'll maybe leave them at the end. Um, so yeah, the overlap is just something like, all right, we go 500, right? And then instead of going to the next 500, we actually go by 80 back, 80 um 80 characters back, and we go like this, and then we finish this and then go 80 back again. And then this is like sometimes you still can have some overlap. Like some people argue this helps, but it differs every time. But for simplicity, I'm just going to be using this kind of chunking strategy. um ChromaDB is open source, so you can go ahead and use it very easily, even for productions ready environments. So yeah, it's not an issue at all. And they support the kind of it's just like easier. They use like they have their pre-built functions like list functions uh, that you can import from Chroma, which kind of makes sense. I mean, to use it because it's packed up with embedding models as well. So you import this library and you can also have your models available for that. So I'm going to be building vector store now. And this is, you would rather not do this every time you do the inference. Maybe you build it once and then that's it. This function needs to be called only once. You don't need to create this a lot of times. It just doesn't make sense. So yeah, I'm gonna be using this model. It's kind of old one, I know, but this is like it's still working and it's cheap and it's for very use cases. A lot of use cases it works. So I'm pretty glad to use it at first and uh, trying to play around and see if this is it. So I'll be building a client, ChromaDB. So you need, in order to initiate your database, you need to create a client and create your collection name. Think of the collection name as something like, for example, in SQL, you would have like a database, and you will have tables inside the database, right? So a collection is like your large database, and you will have some kind of metrics you need to apply. For example, I'm happy with cosine similarity, so I'll use cosine similarity. And next, you need to choose the kind of model you're using for embedding. So this is the model that I initiated, so I'm good to go with this one. Um, yeah, so I'm just gonna have 100 batches. This is just like for default, but you can choose to change this one actually. So yeah, next you go ahead and add the collection into your collection, the documents. So um, so you add your documents. If you want, you can upsert. Upsert is basically like update and insert together. It's two things together. Um, what is the difference between MongoDB collection and ChromaDB collection? Yeah, MongoDB, they're very similar actually in a way that they're storing the data in vector in JSONs. They store it in JSONs, both of them. But the difference is that MongoDB is, I mean, if you use the plain MongoDB, it is designed for table-like data that, I mean, not table-like, but it's not designed and optimized pretty well for vector kind of data. So if you want to search, right? So you store something in your MongoDB, and you want to search from your MongoDB, that is going to be so slow. So this kind of like vector DBs, like Chroma, for example, or Milvus, or anything else, is designed specifically for quick search, and that's what is recommended. I would not recommend using MongoDB as long as it has its own extension for the vector storage. I mean, I know as like this SQL has its PG vector. It's called PG vector. You can you can technically use vector DB inside um, the Oracle DB, but so yeah. So we'll be just adding our chunks and assigning some IDs to them. I'm just going to be going ahead with the basic identifications. Next, I want to build a generative part. So what we did until now was basically uh, this parts where you would, actually there's four as well, where you would embed your documents into chunks, and then you would, sorry, no, actually we're doing this, we're building it, not deploying yet, sorry. So split the chunks, embed them, and store in vector DB. This is what we're just building right now. And we wanna move ahead with the deployment part and add the LLM and the user context as well. So I'm just going to be building a very simple prompt. Your helpful assistant, answer the question only using only the information provided in the context below. If the answer is not present in the context, say, I don't know enough information to answer that. It's very basic system prompt. You define this system prompts in the beginning, and then it is applied to every query, so to say. And then you say you also need a user prompt, so to say. A user prompt is basically, most of the time, this is a question from the user. But since we're dealing with RAG, we don't want to just answer the question by LLM. We want to provide the context first before answering any questions. So that's what you do here. You say, this is the context, this is the question from the user, this is the user question here. And then you're saying this is the prompt, just answer that question. And then you choose your model. This is just the, again, this is old one. You can go ahead with different, more expensive ones if you want. I'm just going to go with this one for now. So yeah, what we do is we say this is the system prompt, this is the user prompt, and choose the parameter temperature. So for this, this kind of problem, I would choose something small like 0 to temperature. So now we don't want creativity here. We don't need a lot of creativity. So 0 to will work. And then, yeah, just return the answer from LLM. That was it. And let's build our class RAG pipeline. So yeah, just some pipeline that we have the components, but we do not have the pipeline. So I'm gonna stack them up together in one pipeline. So this is our client, OpenAI. This is the way we get the PDFs. And remember, this is the file. So if there are no PDF files, just raise an error. I mean, pretty understandable. Chunks, IDs for PDF. Yeah, this kind of stuff. This is just initiation, like the constructor of the class. It is called only once. You're not going to be doing this every time a user sends a query. So it's just for one time only. And we'll have a function ask, which will include the query top K. Top K is basically the top four, like how many relevant items we want to retrieve from the database. If we have like thousands of chunks, we want, let's say, the most like 4 most similar chunks to your queries. So I'm just going to go with 4 for now. And then you see this collection has been created before. This is what like the function that we had to create a collection. So that's basically your, I mean, in SQL system, it would be your kind of database with tables, but if for vector DBs, it's called collection. And in Chroma, you can think of collection as the table, actually, not as a database, because I think they might have partitions as well. I don't want to talk about partitions for this course for now, but some DBs have partitions as well. Like you divide your like your collections into some kind of partitions, but we don't need it right now. So it's just one simple DB. Yeah, when we do self collection query, that's basically we're going to search from the vector DB the user query. This is the user query, and it will be embedded, and it will search top 4 similar items from our DB, and will return those chunks, the 4 chunks that we have. And we'll return the LLM generated answer. So generate answer, remember, is the basically the system prompt, and the LLM, what it responds at the end to you. So this ask is generally, this ask is like the whole rack pipeline is just um, in one simple function. That's it. We just had 247 lines of code, and now you can have a whole system like this. So I will import this rag for now for once, and then while true. So this while true means like while your system is running, just yeah, the system should be functioning. So if you exit, then yeah, your system will not be running and this will become false. But for now, what I'll do is I'm just gonna get the question from the user, right? To strip it. So stripping is like, yeah, just you remove the blank spaces from into the beginning and check if this is not question. Not question means like if it's empty or not. So most probably it's not going to be empty. Uh, so yeah, that's like some basic validation, and then rag. This is the pipeline rag.ask. That's it. That's basically it. So this rag.ask is your whole rag pipeline. So yeah, and I'll print your output to you. Let's just check it. Let's do it. Let's do pre-check. So I'm gonna go with Python rag intro dot py. First, we'll load the database. You see for every PDF, you got how many chunks. Like here, we don't have a lot of chunks, but still, it's pretty relevant. We'll store it in the ChromoDB. And then the system will be ready. So you can ask your question. So let's say I want to ask one question about, I mean, I don't know, let's see. Jupiter, the eighth and farthest known planet from Sun. I'm gonna ask, what is the farthest planet from Sun? Is Neptune. Yeah, there you go. It's pretty clear. You can ask any other questions. So, but basically, you see, it's so fast, so fast. You don't need to like imagine you gave this whole PDFs, everything to ChatGPT, just uploaded this to your ChatGPT and said, what is the farthest planet from Sun? Then it would think like maybe 1 minute and then answer you. But now we have a very efficient system that can do this, and then it will cost you less for sure. Just a couple of details to mention. That's pretty much it. I'll go with the questions now. So let's see what we got. Give us an example using, okay, I already gave this 550K example. Can you say again? How can I solve the embedding rate limit in the above code? Oh, I think it will require some time. I'm just gonna go ahead because we've got like 10 minutes. When doing embedding, is it better to process images and tables separately? It's better to process images and tables separately. Yeah, I think it's better to do them separately because you might want to have an image embedding model, a table embedding model separately. So mostly, yeah, separate, making them separately and using multi-rag system would do the job. The difference between Chrome and Mongo. When building system prompts, I noticed that some features work well at first, but becoming consistent or laggy over time. In such cases, is it better to keep improving the system prompt, or is that usually the point where developers should move to vector database? Yeah, this kind of question, yeah. So if you have a lot of data, yeah, you need to go to RAG system, 100%. If you have small data, if we had like one PDF like this, Venus, and that's it. I mean, most probably I would still use RAG, but maybe just prompt engineering would work here because it's small data set, and I mean small, just 2 pages is not going to be a huge problem to answer any questions from this. So yeah, if you have like large windows, like large text, and your system becomes laggy, then yeah, go ahead with RAG, of course. So I'm not sure what this is. So okay, deployed and integrated with the front end RAG. Oh, okay, embedding table. Please check my comments. Oh, okay. So this is like your these are your tables. Okay. So I think if you have tables, just maybe wait a little bit because I don't know about your tables, honestly, but RAG system is not very good with tables. It's very good with PDFs and some of the text related features, but not like tables. Just maybe you need to wait a little bit and see what the other guys will tell you about agents in next sessions. So agents are actually more useful with tables, but just wait as maybe you need to think a little twice before using RAG. Never share your API key publicly. Good point. Okay, so basically the RAG is something like notebook LM, right? Yeah, I mean, yeah, it's RAG is just the system, not sorry, RAG is the algorithm, not the product, so to say. So yeah, that's basically it. But the good thing about the algorithm is that you have more control over your algorithm. In Notebook LM, you might not have that control, so you might be limited. It's a high level RAG. So yeah, just think about that as well. Yeah, with system prompt right now, very big around lines of code are just the system prompt. Oh, that's a lot of lines of code, but again, I don't know what kind of thing you're solving, but um, so 800 seems too much. Yeah, how can you reduce it? If you provide a lot of the concept, a lot of context to your LLM, it can get confused because it's like there's a lot of things going on. Just be more like provide as a simple thing as possible. But yeah, I mean, think of it like try the simple system prompt, and if it doesn't work, expand and expand it more. But 800 lines of code seems to be large. How do you use AI in a structured lesson without it turning into open-ended chat that ignores the curriculum? Use AI in structured lesson without it turning into an open-ended chat. And structured lesson. So what is meant by structured lesson? Mohideen. Structured lesson without it turning into open-ended chat that ignores the curriculum.
I think what Mohideen meant was that if you have like a curriculum that a student should go through, how to make sure that they go through the curriculum that is given without going to some random topics which are not related to the curriculum.
So yeah, so I mean, if this becomes an open-ended chat, then most probably you have a chat history, and it will. Yeah, I see. So yeah, just do you have this kind of thing here? Like you have context from RAG, you have chat history, user question system rules. If you have this kind of stuff, then basically first thing you might try to do is add that to your system prompt and say, yeah, just don't fall into this trap of open-ended chat. If this doesn't work, well, like the thing is you need to retrieve, well, you need to know when you need to retrieve and when you do not need to retrieve. But I don't know, maybe your use case is different. Maybe you need to retrieve every time. I don't know. So yeah, it's just kind of complicated now to answer, honestly. If like there are like some variables I don't know.
For example, I just have an example. Like you have a math topic that you want to explain to students, and they can go through the chat system that the participants built, like not just chat system, but the AI tutor that teaches math. And you want students to proceed like step by step, not like jumping through and going outside the curriculum. How would you like implement that? So we have lesson one that talks about, I don't know, uh, theorem of Pythagoras, for example, and people need to kind of learn the basics and then kind of go through that.
So the users will be asking questions about any topic, right? So anything, not just the modules they're in, or
Uh,
um,
uh, Yeah, like a AI tutor for math for school kids, for example.
yeah. Um, so yeah, I think this is uh, it's and you have like a lot of data, right? So like a lot of stuff going on. So
School books could be a resource for that, like a RAG for RAG, I guess, pipeline.
okay, okay, so you need to add I mean this kind of stuff, yeah, it's yeah, I probably can answer that like separately if you send me the well, I mean I can provide the answer. So just need more details, I guess. I'll talk to you about this. It was very big around internet. Okay, how do you use AI? Okay, how can I message you privately if I briefly describe the problem I'm solving? Yeah, yeah. Okay, sure. Can do that. You can message me privately. Um, yeah, sure. I can share my LinkedIn as well. Um,
Actually, we had your LinkedIn shared in the Instagram post. If you guys can follow, you can see that and all the posts that we had. But yeah, it is there. Just wanted to say. And I think like if you have the answer for this specific question from Mohadin regarding this like tutor, AI tutor, I would take this answer and then post it in the chat for the group to see as well.
sure, sounds good.
Thank you.
Okay, I mean, looks like that's the only thing left. So, uh, any other questions, or we can wrap up?
I think it was great. Yeah, thank you so much for your time. And yeah, I guess we have the information that we need to proceed with the projects. This was the like kind of the last topic for the first milestone. So yeah, thank you.
Thanks everyone for joining. So yeah, as discussed, I'll provide more details. But I mean, I'll speak to Munir and we'll discuss more about this and let you know about the answer. So thanks a lot. Yeah, I'll see you guys next time, and yeah, hopefully you can build some rack system in your projects. And yeah, thank you.
Thank you so much for your time. Thanks.